The last section, let's look at how to find equations of perpendicular lines. Here is the graph showing two lines, they are perpendicular. That means the two lines form 90 degrees angle. So let's look at the theorem, criterion for perpendicular lines. Two non-vertical lines are perpendicular if and only if the product of their slope is -1. So here the if and only if, that means two sentence, okay, which is showing in the next two slides. If two non-vertical lines are perpendicular, then the product of their slope is 91. And then the other way around, if the two non-vertical lines have slope whose product is 91, then the lines are perpendicular. Okay, so if and only if just means from both directions the statement is true. So the proof of the criterion for perpendicular lines, there are different ways we can prove it. One can use Pythagorean theorem to prove it, or we can use the geometry knowledge, okay, to prove it. Geometry knowledge is little short and easy to prove, so I'm going to show you here, and then use the Pythagorean theorem to prove. You can find a YouTube video, okay, showing the process. So let's see how we set it up. These two lines are the two perpendicular lines. Okay, you see here is the 90 degree. And then if we draw a vertical line, okay, at unit of 1, okay, we draw this vertical line here, and then we form right triangle, right? AOB, this is a right triangle. Because this line is joined when here is 1 unit. Okay, that's why if we say this is L1, this is L2, and the line L1 with slope M1, and the line L2 slope with M2, and then we can easily see the rise over run for this right triangle, okay, rise over run, that's M2, right? Where run equals 1, that's how we graph it. So if run over to 1, that's simplified as rise over 1. Therefore, rise actually is the same as M2. Okay, so here, this distance actually is the same value as M2. Therefore, we can, find the coordinates of A, which is x coordinates is 1, right? That's where we draw this line. And then y coordinates actually is the slope of line 2, which we use M2 to represent. And the same reason for point B, we can use M1 to represent. Okay, so now in the triangle, if I call this point as C, AOC, this triangle, okay, it's right here, AOC, is similar to the other triangle right here, which is BOC, okay, it's right here. This is a BOC. This is a AOC, this one BOC. These two triangles, they are similar figures, right? They are similar figures. So which angle equals which angle? This angle actually equals this angle. Can you see? The angle AOC is the same as angle OBC. Okay, and then the two similar figures, their sides are proportional, right? So this length over this length, which is OC over AC, right? The adjacent sides of this angle over the facing sides of this angle should equals this angle's BC over OC. Is that right? So OC, that's equals 1, right? That's 1 over AC, that's M2, right? Equal BC, that's M1 over OC, that's 1. So when we set up this proportion and then cross product, they're equal. So we know M1 times M2 equals 1. So that's from geometry method. We can find out the value. Okay, we're not talking about the positive or negative here. We only talk about the length of the sides of the triangle. Okay, have this property, which is M1 times M2 equals 1. And then now let's look at the sign. Okay, determine the sign. The L1 is this line, right? L1 is this line. So that's decreasing line. So M1 is a negative slope, right? And M2 is increasing line. So M2 slope should be greater than 0. So that's why one positive, one negative multiply. So M1 times M2 should equals -1. Here we should put an absolute value equals +1. Okay, because we only talk about the length of the triangle size. So just from the length point of view, that's why we talk about absolute value. Okay, M1 times M2 absolute value should equals +1. And then from the sign of the slope, we can tell M1 slope is negative and M2 is a value positive. So M1 times M2 should be -1, which is proves the criterion for perpendicular lines. I hope that makes sense to you. And then you can also use the right triangle A squared plus B squared equals C squared to prove. Use the distance formula, you can prove this criterion as well. All right. So now let's look at some example how to use the property of perpendicular lines to find the line equation. Find the equation of the line contains the point 1, -2 and is perpendicular to this line, and graph the two lines. So given line x plus 3y equals 6, and then we can find the slope of the given line. And then we can use perpendicular lines of property to find the line we're looking for, right? The slope of the line we're looking for. And then we know the slope, we know the point the line passing through, and then we can find the line equation. And then of course we can graph those two lines. All right, so let's do it step by step. First, let's find the given line slope. Okay, so subtract x on both sides of equation. We have 3y equals -x plus 6. And then both sides of equation divided by 3, we got y equals -1 over 3x plus 2. So slope of the given line equals -1/3. Okay, we call it M1. So what about its perpendicular line slope? If M1 equals 1/2, and then its perpendicular line, we call it M2. This 2 multiplied should equals 91, right? We can just solve the M2. So that's -1/3 times the perpendicular line slope equals 91. And then negative cancel, so M2 should equals multiplied by 3 on both sides, right? M2 equals +3. So now we know the slope of the line we're looking for, and then we know the point. This denoted as x1, y1. We can use the point slope form find the line equation. Y minus y1 equals m times x minus x1. So y minus -2 equals 3 times x minus 1. And then simplify y plus 2 equals 3x minus 3, and add subtract 2 on both sides of the equation, so y equals 3x minus 5. All right, so now we can graph. Okay, this is the line we're looking for. Slope 3 at 3, y equals 3x minus 5, that's the line equation. Okay, the slope is 3, the y-intercept is -5. So we can graph using the y-intercept 0, -5. And then every 3 units rise, 1 unit run, right? 1, 2, 3 units rise, 1 unit run. So we can easily get this point with coordinates 1, -2. And then use straight line connect these 2 points. That's how we got this green line. And similarly, to find this blue line, okay, earlier we got a line equation, right? Y equals -1 over 3x plus 2. So the y-intercept is 0, 2. We plot the y-intercept first. And then the slope is -1/3. So that means every 1 unit down, 3 units to the right. So 1 unit down, 3 units to the right. So that's given us this point with coordinates 3, 1. And then connect these 2 points, we got this blue line. All right. So that's the last part of this section, okay, 2.3. Just one last thing to mention. When we say the product of 2 lines equals 91, and then actually you know there's another way we can interpret it. Okay, we can say one line is negative reciprocals of its perpendicular line. Okay, if you memorize in that way, that's fine as well. Sometimes, you know, it's kind of easy to do negative reciprocal. Okay, you can see this line slope is -1/3, and then negative reciprocal will be positive, and then numerator denominator flip, so its perpendicular line slope should be +3, right? Which is just matching our solution as well. Okay, so it's up to you to use which way to find the slope of perpendicular lines.